I'm really happy to be here and happy to have an opportunity to talk about insects at a rendering conference. I will ask you to forgive me if I cough. I have that like 100-day lingering cough that went through the US over the last 6 months, so I will do my best to not interrupt my talk. So I'm going to talk to you about black soldier fly larvae and how they contribute to sustainable agriculture. And I want to emphasize right from the start that we're talking about contribution to sustainable agriculture. I think in the last 10 or 15 years, the insect industry has had somewhat of an emphasis on replacing and being a better solution than traditional proteins. And I think our perspective is that we need more protein and energy in the world to feed our growing populations and to feed our animals. And we view insects as just another solution that combines with all of the other exciting opportunities we're developing in animal agriculture. So we are focused on changing the world with one sustainable ingredient at a time, and we are wholly owned by Darling Ingredients, so I'm very proud to be part of that organization. So I'm going to talk to you a little bit about why the black soldier fly larva. There are 3 insects that have been commercialized or been attempted to be commercialized: the cricket, the yellow mealworm, and the black soldier fly. The black soldier fly is a really exciting species because, number one, it's native to every continent. It's not invasive. It doesn't present any agricultural pest risks. It doesn't carry any zoonotic diseases, so we don't have to worry about disease transmission from the insect to the animals that feed on it or to the humans that work in our manufacturing operations. And it has an incredibly fast life cycle. So we think about chickens or pigs or cows or soybeans, excuse me, and how long it takes us to go from initial planting or initial start of a feeding an animal to market. We can take our animals to market in 14 days. It's a lot of life cycles in 1 year to generate protein. If I can use the pointer. So this is an adult black soldier fly. If you have a compost pile, you have seen this animal. You just might not recognize that it's a fly. It has no defenses other than it looks kind of like a wasp. So most people, when they see it, think it's a wasp species, and that's its method of protecting itself. The adult fly lives for about a week. Its sole purpose is to breed, lay eggs, and pass along its genetics. One female fly lays about 1,000 eggs in her clutch. Those eggs hatch in 24 to 48 hours, and then those larvae grow exponentially to harvest weight. They grow about 20,000 times their body mass in 14 days. It's astounding what they're capable of creating. By the way, for those of you who are really familiar with animal ag, our harvest weight is like 150 to 200 milligrams. So you think about your chicken or your pig or your cow. These are very small animals, but we can grow a lot of them in one environment. We harvest our animals at about this life stage. This provides the optimal digestibility. So once these animals go through their later life stages, this exoskeleton becomes more sclerotized. It analyzes as nitrogen, but it is not as bioavailable or digestible. So most folks are harvesting in these life stages where digestibility for animal feed applications is at its highest. The lucky few, 4 to 5% of the larvae get to stick around and go back to become broodstock. And that life cycle is it's a total of 30 or 40 days. So really, really fast generation time. One of the other reasons why this is such a sustainable opportunity is we could farm vertically. Okay? So we have a 3D plane to work with when we're farming our animals. So this is an example of stacks of trays in our plant in Kentucky. They go about 20 feet high, which is somewhat common now in industry. And so I have 3 dimensions to work with, and really it's the engineer's, dream of how high can we go. Combine that short life cycle with vertical farming. Also, the insect's 100% edible. We don't have to take off hooves and hides and hulls in order for it to be useful as an ingredient. That creates incredibly high yield potential. The data on the bottom represent peer-reviewed publications, so university scale trials about what the potential is for yield, edible protein yield per acre per year. In a commercial plant, we're now achieving numbers for insects of 1 million pounds of protein per acre per year. So at commercial scale, these are the opportunities for creating sustainable ingredients are tremendous. We get asked a lot about our carbon offset and how sustainable these insect-based ingredients are. This is a debatable field. So what I'm presenting with you here is two different kinds of LCAs looking at greenhouse gas emission potential. So this is a mass-based or an economic-based LCA, excuse me. There's a lot of ways to look at these data. I think the important thing, and this is in comparison to primary protein, so chicken meal, pork, beef, et cetera. This is not looking at comparison to byproduct meals, which have obviously a much lower carbon footprint. But this is our product. This LCA is conducted with our facility and our ingredients. So on a mass-based or an economic-based allocation, we have significantly lower carbon footprint greenhouse gas emissions coming from black soldier fly larva production. The other reason why we really like this insect is because it's truly an omnivore. It can eat just about anything. There are a lot of regulations, particularly in the United States and in Europe, about what it can be fed and still create an ingredient that is allowed to be used in the animal feed industry. But in theory, you can feed them just about anything. They're amazing at bioremediation of waste streams from food, the feed, and from other industries. In the United States, they have to be fed AFCO approved or generally recognized as safe ingredients. That means pre-consumer food waste is available, so grocery waste, for example, or waste coming out of the food and feed manufacturing industries. In the US, we cannot use post-consumer food waste. If it's been on a plate, it's no longer allowed to be fed to the insects because of concerns of microbial contamination. We can feed things like offal. We can feed rendering byproducts. We can feed manure. There's a tremendous amount of things that can be fed to these insects to upcycle what would be landfilled or land applied. Again, there are regulatory questions that have to be answered if you select certain feedstocks. For example, in the US, if you want to use manure, you will have to spend time with FDA and USDA documenting safety of the finished ingredient. At EnviroFlight, we focus on byproducts from the distillery industry. We are based in Kentucky. There's a whole lot of distillery byproducts coming from the bourbon industry. And our bugs really, really like that feed ingredient, as we all would. So the thing you have to be careful of on feedstocks is that these insects do reflect their feedstock. So in some respects, they are what they eat. That's important for fatty acid profiles. If we feed fish offal from the salmon industry, we'll get an omega-3 enriched bug. If we feed offal from poultry and swine, we'll get more of a poultry and swine-based fatty acid profile. What's also important is that they will bioaccumulate, and I can't read it either, but they will bioaccumulate heavy metals. So we have to be very, very mindful of our inputs to make sure that we're not getting insects that have extremely high levels of, say, cadmium, lead, or zinc, or arsenic. They will also accumulate zinc, iron, copper. So you have to be very, very mindful on the mineral side to make sure that your feedstock does not present a source of contamination that would be transferred to the animals that we're feeding. At EnviroFlight, we produce 4 major products. These are common in North America. In the EU, it's a little different because the whole dried insect is not a primary production ingredient. We produce whole dried larva. This was our first regulatory approval in the United States. That's going primarily to reptiles and backyard poultry. And then from that whole dried insect, we render out the fat and we create a high protein meal that runs 50 to 55% protein, 9 to 10% fat. And then the oil. It's called oil and it looks like oil in this picture, but it's about 40% lauric acid. So it actually is more of a fat because it is solid at room temperature. Melting temperature is about 80 degrees Fahrenheit. That lauric acid is totally dependent on diet. So if you change the feeding program, you can change the lauric acid concentration, but provides in our program with a high carb diet, you get a really nice enrichment with lauric acid. And then finally, this is our biomass. It's called frass, and it's the remnants of what the insect has eaten, digested. It also has exoskeletons. As the insect goes through its life cycle, it will molt. And those exoskeletons, which are an amazing nutrient source for soil and animals, end up in this frass. This is processed. This is heat treated, so it goes through a kill step and then ground into a uniform particle size. In the United States, that can be marketed as an animal feed ingredient. It has excellent feeding value for catfish, tilapia, chickens, and pigs. It also is a great natural fertilizer, and I'll show you a little data on that. So in addition to, I would say, our straight nutrition, and Dr. Wu, our amino acid digestibility is better than soybean meal, more like a byproduct meal. So we provide excellent nutritional opportunities for feeding animals, but there's also these value-added components that come along with black soldier fly larvae that are super exciting. Number one is lauric acid. So we heard about the value of lauric acid as an essential fatty acid or providing fatty acid nutrition. Lauric acid also has potent antiviral and antimicrobial properties. We also know that insects in their natural environment produce antimicrobial peptides. These are tiny little peptides that act kind of like natural antibiotics, and they survive processing. So we see efficacy of these small peptides in the animals that we feed with these ingredients. And then that exoskeleton has chitin, and in the right amount, chitin acts like a prebiotic and helps regulate the gut bacteria. So the data I'm showing here are from a couple examples of research in fish. So this is trout data. In the trout trial, we had fish meal fed animals, we had soybean meal fed animals, and then we added only 5% of our black soldier fly larva ingredient to the soybean meal fed fish. And I think we heard today, soybean meal fed fish tend to have enteritis and tend to have little poor health than animals that are fed fish meal. And what we see is by adding a little bit of that black soldier fly larva to the soybean meal based diet, we completely ameliorate the enteritis. And that we believe we're doing that because we've completely shifted the microbiome. So we've changed the gut microflora of those animals by feeding really small amounts of these very potent functional nutrients. The data here on the right represent feeding frass, that biomass. This is to catfish. So this is the commercial catfish trial. We had 80,000 animals on a commercial farm, went all the way to harvest. This is the improvement in yield with a 20% inclusion of our frass in catfish diets. And this is the reduction in mortality. We see the same impact on gut microflora that we do with the whole dried insect. So there's some really neat functional properties that are coming with these ingredients. And then I can't ignore fertilizer. We just talked, Ethan just explained to us how our ingredients could function as fertilizers as well. And the same is true for frass from insect production. So frass actually has a relatively low NPK. So from a fertilizer basis, it wouldn't be viewed as something to replace a chemical fertilizer. But what we find is that it has really slow release nutrients, and all of those value-added properties that we see in the animal feeding application seem to parlay into the soil microbiome. And so we get longer term positive benefits of frass than you would predict just on the nutrient content. The picture here on the left is horseradish. So this is without frass, and this would have been used with a chemicals fertilizer. This is with frass applied at the same NPK rate. And what's really exciting about this is not only do we have visibly improved plant health, but we had significantly reduced discoloration in horseradish. It's the number one reason for horseradish to not be sold is that they get discolored, and it's because of fungal pathogens. And so these data and this trial demonstrated we could reduce the fungal pathogens in this field of horseradish and significantly improve yields for the farmer. We see similar responses with a lot of other crops. We've done this with kidney beans, with potatoes. There's a whole lot of data out there showing you get significantly improved yields beyond what you would anticipate from an NPK or pure nitrogen basis, likely because of the impact we're having in the soil microbiome. Quickly, I'll finish up with the current U.S. regulatory status. So when I started with EnviroFlight in 2017, we had no regulatory approval. So it's really exciting to make ingredients that you can't sell anywhere. So we worked really, really hard with AAFCO and FDA to demonstrate safety and applicability of our ingredients. And so I'm really excited. This is as of the last AAFCO meeting. We have approval for just about every species now with black soldier fly larvae. The exception is ruminants and horses. So to my knowledge, nobody has moved into those fields with these ingredients yet. Frass, the EnviroFeed, is approved for all species. And I know there's a crustacean definition coming through. So by 2026, we'll have basically everything except cattle and horses, which is very exciting. Canada follows similar regulatory pathway. So at least North America is generally represented here. So I'll just finish with kind of the theme of the circular economy. We're really excited about the black soldier fly larva and what it can do. We can upcycle byproducts from just about any industry, create high value nutrition that we can feed back to other animals. And we're really excited with frass that we can either turn that into a valuable addition for soil health or put it back into the mouths of the animals that we want to feed with our primary ingredient sources. If you have any questions, I'd be happy to answer them. And thanks for letting me talk about bugs at a rendering conference.